Hello and welcome to another session where today we are going to explore a little further some basic logic puzzles. Now, we're not going to use formal logic or anything fancy, but there's logical reasoning, deductive reasoning in the background to try and navigate and make sense of these puzzles. So we're going to look at this first one. Let's read it together and then we will elaborate on the important parts. You're in an empty room with 3 colored locked boxes. Only one key and some instructions. Exactly one of these boxes contains a treasure, some gems, while the other 2 are empty. At least one, so one or more of the boxes has a true statement. At least one or more has a false statement. We want to determine which box contains the gems and of course understand and explain our, at least navigate and track our method and our reasoning through this. So we're not going to write an essay here. A lot of this is going to be verbal and we're going to track on our page what we're doing, but you can of course elaborate more if you have to answer a test or you have to explain it to someone else. We're going to keep the actual writing down to a minimum because we're saying those things anyway and you can write it down from what we're saying in this video. So these sentences are very important, that we know there is a true box and there is a false box, but we don't know. The third one could be one of the 2 true ones or one of the 2 false ones. We don't know all of them and we don't know which one it is either. So here are the statements. The gems are on the desk, the gems are in this box, the gems are on the floor. Okay, so I'm going to move this so that we can have more space. And I wrote down what each colored box says because we're going to have to remember that and probably look at it, refer back to it over and over and over. So with this kind of puzzle, this kind of problem, there are many different strategies. Throughout, I'm going to demonstrate a few different strategies, but it is certainly a challenge to face a problem and now come up with a strategy. It doesn't have to be the absolute best strategy. Very often these have multiple ways of going about them. As long as you make a plan, stick to the plan, and if it seems strange or you run into problems down the line, we can come back, update the plan. So with this, I'm going to, not sure what this is. I'm going to just demonstrate a few different strategies. Well, let's play to our strengths and stick with something that we've seen before, which is Lady and the Tiger problems, knights and knaves. Those are certainly ones we've seen very often, and it does make me think like that, right? There are 3 things, there are some things that are making statements. So, what is this? Some weird anomaly. So, I'm going to break it down into 3 columns. Let's explore what the blue box is saying. Let's go white. There's an order here, and black, and then look at the different possible combinations of contents that these boxes could have, because I know a lot about that. I know there is one with the contents of gems and the others are empty. So we could say, oh, maybe the gems are in the blue box, then these ones are empty and empty. That's one scenario. Or we can have empty, this one has gems, this one is empty. Or we can have blue empty, Oops, that was supposed to be an M. Empty. And the black one has the gems. So what's nice here is that these are the only possibilities. There is nothing else given the structure and the limitations of the problem. This is it. This is it. So I know the answer is one of these three. So now I'll just go start at the top and explore if this combination, if this first row is possible. So now I have to, of course, remember what the boxes are saying. Blue. Blue says the gems are on the desk. Well, in this scenario, no, the gems are in blue, so that's false. White says the gems, white, this is white, I don't want to mix these up. White, the gems are in this box. That is false. Black says, this is black, the gems are on the floor. No, the gems are in a box. It's not on the floor. So that's also false. And now I go to the essentially the rules for this puzzle, for this game, that at least one of them is true, at least one of them is false. In this scenario, all three are false, so that is not possible. Don't be confused with the black and the white box here. I'm looking at the lines to represent the color, just how I chose it. Then, so this is out. Nope, it's not happening. It's inconsistent. It doesn't match all the information that I have. Then I just go to the next one. Empty, gems, empty. Blue says the gems are on the desk. No, the gems are in a box, not on the desk. Regardless of the contents of blue, its statement is false. White says the gems are in this box. Given this that I'm exploring, that is true. Black says the gems are on the floor. No, they're in a box. So, given all the information I have, at least one of these is true and at least one of these is false. This is certainly possible. Now, unless this is some trick question that can't actually be solved, assuming there is one answer, this would be it. But if we don't want to make that assumption, we want to be more clear and confident, we would have to eliminate and explore all the other possibilities. And if this is the only one that remains, okay, now I am 100% sure the problem was solvable and this is it. So let's explore the last, for practice anyway. Empty, empty gems. Blue says the gems are on the desk. No, it's in a box. That is false. White says the gems are in this box. Not this time. That's false. Black says the gems are on the floor. No, they're in a box. So that is also false. And I got no true statement anywhere. That is not possible, but that is a good thing for where I am in this problem, because it shows that this is also not possible. In my list of 3 possible results or answers that could happen, I eliminated all but one, and therefore this one must be correct, and the gems are in the white box. All right, let's look at the next one. Same rule, same setup. At least one of the boxes is true, at least one of them is false. And we have exactly one box with gems in it. Here are the 3 statements. And let's move this up so I don't need it. I copied them over here. So now, the whole point of this discussion is to demonstrate different starting strategies that could be viable. And I don't want to feel boxed in with a strategy. Oh, I have to use this strategy. No. go with what you feel makes sense, and once you have a plan, stick to it. If you don't like it later on, come back to the start, think, ooh, what else could I have done here? Is there maybe a simpler, smoother path through this? And it starts with my strategy. So I want to demonstrate some different strategies. Well, we can still list our boxes. Blue, no, let's go white again, and black. But this time I'm going to list all the true-false combinations that they could have in their statements. Now, you might be tempted to say, oh, this is the first, or a first option. I want to structure my list in a systematic way so that I have a complete list, right? But this is not a valid possibility. I don't need to list this because I know there is at least one true, there is at least one false. So one option for a combination is to have two trues and a false. So let's change this guy to a false, but it can also be true, false, true. And it can also be false, true, true. Are those the only ones? Well, no, there could be two trues and a false, and then yes, I do have at least one of each, but it could be two false and a true, and then I still have one of each. So we could go false, false, true. We could go false, true, false, and we can go true, false, false, and those are also valid. Now, don't immediately dismiss this just because I have a longer list of things to check. Sometimes the length of this is deceptive, and if each one is super easy to check versus something that seems short but it's more complicated to navigate, this one might actually be simpler. I'm looking for something straightforward, that I know that if I just work through this, I'm going to get the answer. There is no real complexity. With the right choice, with an appropriate choice of strategy, I remove a lot of complexity, and then it's just a matter of time. Time is not the issue here. Complexity is the issue. So let's have a look. So now I'm looking at the top scenario. I might as well start at the top. I just randomly listed these, right? You could have made a list that looks different as long as they still have 6 of options. I need my list to be complete. So now let's have a look. Blue says, there are 3 boxes in this room. That is true. It's supposed to be true. That checks out. White says, white is this one, 2 boxes in this room are empty. Well, based on the setup of the problem, only 1 box has gems, so 2 boxes will always be empty. This is true. It's supposed to be true. Black is over here. Black says, this box is one of the 2 empty boxes. Well, in my scenario, that is a false statement. This box is not one of the 2 empty boxes, which means it has the gems. There is nothing here that contradicts any given information. But it might be a little strange for you at this stage because it's also the first one. So I'm not sure perhaps at this stage, well, how would I get a not possible? I'll just write possible here for now, but I do understand that it just happened to be the first one. Let's see how the others are not possible, and then when I look at this again, I'll see. Because my general strategy is still the same, I'm aiming to eliminate all but 1, and that will be the correct answer. Where that 1 appears in my list, I don't know beforehand. It seems like it was the first one I wrote down. But I do need, for confidence, to examine the rest, right? So now we're going to the second row. Blue says, there are 3 boxes in this room. That checks out. That is consistent with how it's supposed to behave under my assumption of this row. It is true. White is next. White says 2 boxes in this room are empty. Well, I know that this is true based on the description of the problem. So I cannot assume it's false. That does not match with information that I already know. I don't care what the black box is saying. There is an inconsistency in how white is behaving. So that's not possible. Not possible. But I hopefully noticed that once I get the hang of this, checking each row is going to be super fast. So the fact that there are 6 is not something that I even consider as an issue. Let's check false, true, true. Blue says there are 3 boxes in this room. That's always true because that's the setup of the problem. It cannot be false. So immediately there's an inconsistency, and this scenario of blue saying something false is not possible. See, that was very, very fast. Let's check the next one. If we start remembering what the boxes say, blue cannot be false. Blue is true. There are 3 boxes in this room. So anywhere where blue is false cannot be possible. So it's actually much faster than it might have originally seemed by just looking at the size of the list. And I only have 1 to check. So quick. Now blue checks out because in my assumption blue makes a true statement. Yes, blue in fact does make a true statement, so it's not going to throw out this possibility based on what blue says or how blue behaves. White says, white in my assumption is false. White says 2 boxes in this room are empty, but that is always factually true. That's the problem I am working with. So this time white is a little bit of a problem. It is not consistent with how it's supposed to behave according to the rules of this puzzle. And you see very quickly that the one I happen to have listed first is the only one that is consistent with all the information, and therefore that has to be the correct answer. So there's a lot of lessons here. Even if you like the strategy or not, and even if you're never going to use this, there's a lot of lessons here that I'm aiming for a strategy to simplify the journey through the problem. At face value, something that's longer and bigger might still have that simplicity. I don't want to dismiss it just because of appearances. And that is something worth thinking about. All right, we're on to the next one. Now again, my goal here is to demonstrate different strategies. One isn't necessarily better than another. It's just options that I have available that I can consider and pick one that suits me the best. Now, in these last 2, we'll use a strategy. The rules are exactly the same, so I'm going to move up this window here. We're going to take a strategy, I'll say the wordy approach, of just reasoning through it, starting at whatever statement in whatever place suits us. Sometimes a simple statement. So let's just scan through what these boxes are saying. The blue box is saying this box is blue. Black box is saying this box is black. White box is saying the gems are in a true box. So definitely the first 2 have simpler statements, easier to evaluate. So in this strategy, I'm writing full sentences to explain my deductive reasoning. And we have a bunch of premises already, right? The description in the problem is all the information that's factual that we have already. So I'll scroll back and forth to see. We're going to start with this blue box and say that, well, the blue box is saying this box is blue. So we'll start by saying I'll make it capital, sure. The blue box is necessarily true. It's making a very simple statement that I can evaluate. It is true. The black box, if you remember, is saying this box is black. That is always true. Regardless of the content of where the gems are, the black box is also always true. Now, because, or let's say since, at least based on the information in the problem, and they're always the same, this is the third one we're doing now, since at least one box is false, it can't be blue, it can't be black, because they're always true, we conclude, sort of a temporary intermediate conclusion, that the white box is false, because there has to be a false one somewhere. Can't be blue, can't be black, has to be white. So we're doing sort of a little elimination here, and we started with the simple statements because they're easier to get a foothold, start some momentum. So now we know blue is true, black is true, white is false. And now we can look at what white is saying because we now know a little bit more about the white box. It says the gems are in a true box. That is false. Let's just slow down and think about it carefully. So this statement is not true. So the opposite is true. When I say the gems are in a true box, that's false. So what do we know? So we now know the gems are in a false box, the opposite of what white is saying. And white is the only false box. So white is the only false box. Let's move this up a little. And so, that's weird, what is this? Weird E. And so we conclude that the gems are in the white box. So see, different strategy, though we are using similar principles inside, but this strategy requires that I start somewhere, and that changes depending on what the statements are. Often it is going to start with a simpler statement of the bunch, and then I have to follow that. Okay, what does that? I make a little conclusion that leads to another conclusion that leads to another conclusion, which eventually leads to the final conclusion for where the gems are. More advanced because it's a little bit more flexible navigating through this sequence of sentences in my argument, but it also has the benefit of being quite efficient if I can correctly navigate it. Everything I'm saying, or every conclusion I'm making, has 100% confidence. Just an alternative strategy, so you know your options and you're aware of what suits you and what might be a good starting point for you. We could certainly have done this with one of the previous strategies. I'm just trying to mix it up to give you some options and see how these compare. All right, let's do one more, because I'll call it the wordy strategy. I guess the more pure deductive reasoning strategy has some complexity to it. There's a trade-off for that efficiency that some might struggle, and I don't want you to feel forced to use it at all. I'm giving you the options. You can do these problems really with any one of those, probably, those strategies. But let's go through another wordy one. Same setup, different statements. Let's go. So let's see what they're saying. Blue box says this is the blue box. So immediately I'm thinking, this is a very simple statement that I can evaluate without knowing anything else. Mental note. Black box is saying the blue box is empty. So I'm thinking, you know, it's a simple statement, but I would need to know more about the contents before I can reliably evaluate this. Medium level. It's not helping. It's not a starting point necessarily, and not an easy one. I could go on an assumption of, let's suppose the blue box has gems versus not. Then I can follow the black box and see what it says. That's a little bit more complicated. So blue is definitely easier so far. And then white says the blue box is true. Okay, that is a simple statement. I would need to start with the blue box first, though, before I can say anything here. So based on this initial, knowing my strategy is going to be the wordy one. Based on this initial run through and scan, the blue box is a good one to start with. That doesn't mean I'm going to start with it and it's going to work perfectly. Well, okay, it is in this case because I planned it. But we have to let go of requiring perfection right away. I could start with a strategy and, it is just going to be a disaster. But I'm still learning from that. And it's okay to backtrack and say, what else could we have done? Let's try something else. Now I'm demonstrating the specific strategy here. But if I don't like it, and I've started it, I'm like, I don't know where to start. All of these seem complicated. Go for another strategy. It's okay. It doesn't have to be perfect the first time. So let me just go up here and say, and note, we're going to start with blue because blue statement can be evaluated right away. It says, this is the blue box. It is the blue box. That means blue is necessarily true. Sort of a coincidence that the previous example had the exact same starting point. Coincidence. The blue box is necessarily, that was supposed to be an I that turned into an L. True. Because based on, I don't need any other assumptions to evaluate its statement. It's always going to be true. Regardless of where the gems are, regardless of what the other boxes say, this guy's true. So it's a good place to start. Not always going to be like this. That's the challenge of the wordy strategy. So let's now go, now I know a little bit about blue, and white references blue in its statement, saying the blue box is true. Well, the blue box is true. So white's statement is also true. So we can say, therefore, conclusion, little conclusion. White is also true. I didn't know that until I made progress with blue. Now again, there has to be a true and a false. I have two trues already. So we'll elaborate with this sentence. Since there must, oopsie, that's a U and an S, must be at least one false statement, it must be black. Oopsie, I'll capitalize. It must be the black one. That is a weird B. I'm going to go with it. The other two are already true. Black is the only one that's left, and so it has to be false. Now let's look at what it says, because now we have more information before we look at its statement, and we can now evaluate that statement. It says the blue box is empty. We now know that's false. It must be false. So the blue box is not empty. So the blue box is not empty, and therefore contains the gems, because only one box has the gems. So we started with something that is easy to evaluate. That led us to be able to make progress with white and evaluate that. We found two true based on at least a part of the premise of the problem, that there's at least one true, at least one false. We could conclude, well, black has to then be false. That allows us now to evaluate what black says. And if black is false, the opposite of this is true, so the blue box is not empty, and therefore the blue box has the gems. So there is certainly an obvious efficiency here, but everything comes at a price, and the price is to have a reasonable place to start and navigate through this, and that can be really tricky. It's not as simple as the others. The others are sort of, well, if you can list all your options, however you want to look at those options and start eliminating them, it's much more systematic and procedural, and you can just sort of work your way through it, sort of brute force your way through it. This one is a little bit more nuanced, this strategy, in that the path through it kind of is determined by the actual statements. I can set up a strategy like this regardless of the statements. So it's a little bit simpler, which is why we mainly focused on these guys. But I can technically be a little faster if I can handle this complexity. And again, it's not a one-size-fits-all situation. With this, I wanted to give you a demonstration of how we can handle the same kind of problem with a variety of strategies. Whichever one you pick is completely fine if it gets you to the end and you understand what you're doing. All right, that was hopefully successful. We'll end it there. Until next time.